Good afternoon, pilot teachers and students. Good afternoon, class. Okay, thank you very much. You may sit down. All right, in today's lesson, we'll talk about resistance and length. All right, before we go through that, can somebody define resistance? What is resistance? Samuel, you tell us what is resistance.
Resistance is a measure of opposition of a circuit element or section to the flow of charge. The unit is the ohm.
Okay, very good. Samuel has given us the unit of resistance as well as the definition for resistance. Now, it is a measure or rate at which electricity will flow through the conductor. Okay, resistance is a measure of rate at which electricity will flow through the conductor. Now, there are different substances that will have different resistance, and depends on the resistivity of that substance, or let's say conductor. Now, when you go through, you will know that especially there are conductors and insulators. Conductors are those substances that will allow electricity to flow through quite easily. But sometimes you find that from these conductors they are poor conductors and also very good conductors. Now, insulators are those substances that will not allow electricity to pass through. Okay, it depends on the resistivity of that substance. When it goes through, and then when we have a look at the resistance and also the cross-sectional area, you will know some of the resistivity of those substances. Now, also on that resistance and length, you will find that some wires, depending on the length, give us a certain amount of resistance. Enara, can you tell us what type of wires will give us high resistance, especially looking at the size and the length of wires?
The thick wires and like thick wires of copper.
Thick wires of copper. Isaac, can you help Enra to explain that in regards to the size and the length?
The resistance of a wire of a certain material increases as its length increases as its cross-section area decreases, and depends on the material.
All right, good. So from these two, you can see that long thin wires will have more resistance. They will have more resistance, while thick and fat wires or short wires will have less resistance. So from there, we can now move on to the next, or the combination of resistors. For example, right, if you have two wires, if you decide to have two wires, okay, that is a wire R1, and then you have R2. When it decide to join these wires length to length, you have what is known as 2R. So that means the resistance will have to double up, okay, or it increases. All right, looking at the next instance, you find that there are 3 wires that you put that side by side. In other words, they are in parallel. In here, it is in series. So in series, you find that the resistance will have to increase. Or you have more resistance if you have the same wire placed in series. But in here, you have the same wire, but this time you place it in parallel. You find that the resistance will have to decrease. And also considering the length and the size, in here you will find that it is thin. Okay, it is thin and also long. In here you find that it is big, thick, with 3 of them laid side by side, and it is quite short. That is why resistance in here would be less, while in here it will be more. Anyway, when it comes to looking at resistance in series and parallel, you will know exactly why this resistance in series will add up to or increase the total resistance in a circuit, while in parallel it will be less. So that is what we'll be studying later. But anyway, in this lesson we are basically going through and then looking at the length. You can also feature or look at the length of these two, whether they are in series or parallel. In here you have a thin but long wire. In here you have increase in the size of the wire, but it is quite short. That is why resistance in here will be low and in here will be high. All right, quickly have the diagram. Just sketch the diagram and then I will give you the next information. Okay, shall we move on to the... Yes? Okay, here is the next information. That is the resistance of a wire. It depends on the length, and therefore the resistance in series would combine by adding as the one shown in diagram A. So from that you saw the first two diagrams. Okay. Okay. Over to the next. Okay, the resistance of wire is directly proportional to its length. Or you can have it as, okay. Okay, looking at those two, R is the resistance and L is the length of the wire. Okay, if it is proportional, you'll find that as long as the length of the wire increases, resistance will also increase. All right. There are only two questions that you can write down. This is question number one. Copy that, and then I'll give you some time to do that question. For those pilot students, you can also go through and then copy these questions. This is question number one. I'll give you question number two in the next slide. So quickly copy question one, and then do that question. Question number one will be the resistance of a 2 meter of same wire. Okay. If 1 meter is 10 ohms, okay. The question should be what would be the resistance of a 2 meter wire if 1 meter is 10 ohms? What will be the resistance of a 2 meter wire if 1 meter is 10 ohms? No, it is in series. Okay, looking at the first question, some students are asking questions like if it is in series or parallel circuit, but you are just looking at the length and resistance. So what will happen to the length if resistance is that? So since resistance increases with the length, then you have to consider that question along that line. All right, finish copying question number 1. All right, here is question number 2. A wire of 1 meter has a resistance of 20 ohms. Find the resistance of 0.5 meters of the same wire. If you have difficulty in working through that question, you can raise your hands. Samantha, question number 1. Just question 2. All right, just to explain a bit on the wires. Okay, since you have the resistance which is proportional to the length. Okay, the longer the wire and if it is thin, you'll find that it has more resistance. Now, if the wire is short and if it is thick enough, you'll find that the resistance will be low or less. So that is why resistance is proportional to the length. Later on, when you discuss something on resistance and cross-sectional area, you will be able to identify the relationship that exists between this length and cross-sectional area. So for now, quickly copy those questions and complete. Okay, the first question would be Samantha. Get ready to come up and then write your answers with your explanation on the board. Question 2 will be Jos. Okay, we'll now go through the correction to those two questions. Okay, let's have the first person up. Write your answer on the board, and you can explain. Okay, past it.
The question is asking for the resistance of a 2-meter wire, given that 1 meter is equals to 10 ohms. I represented the unknown by X, and to find the resistance, you cross multiply 2 by 10 to give 20 ohms.
All right. We'll wait for the next answer, and then we'll go through together on that. Yeah.
As we all know, the resistance is proportional to the length, and I use the cross rule to find out the resistance of the wire, which is 10 ohms.
All right, that is answers correct. Yes, okay, this is not 200, but it is, okay, 20. So the first one, putting that information into ratio form, you can be able to solve the X or the other resistance. So we have X, which is equals to 20 ohms. All right, that is correct. All right, looking at the second, all right, the solution, you have 1 meter, which is 20 ohms, and then if it is 0.5, you are solving to find the other resistance. So that will be X equals to 20 times 0.5 divided by 1, and you have 10 ohms. So you can now imagine and look at this as, if it is 1 meter, that means the length is quite large. That means resistance will be also large. Now if that is decreasing, or half of that 1, you have half of that 20, which is 10. So resistance is proportional to the length. Right, quickly to summarize or recap on what we went through, resistance is simply the measure of rate at which electricity may flow through the conductor. And it depends on the length of that conductor. If the length increases, resistance will also increase. And later on, when we come to looking at resistance and cross-sectional area, you will know the relationship that exists between the length, cross-sectional area, and resistivity of certain materials. Now, going through that again, there are some materials which are conductors, but that, this time they are made of alloys, or they are alloys, meaning that they are made of different metals. Okay, metals are good conductors, but when you have mixtures of metals, you have an alloy, and there is a difficulty in current flowing through this. And as we go through in our next lesson, you will know why this happens. All right, so that brings us to the end of the lesson. Our keyword for today will be resistance, or key phrase would be resistance and length. Good afternoon, pilot teachers and students. Our lesson for this term has come to an end, and I hope to see you safe next term. Good morning, sir. All right, thank you, Michelle.